I'm going to spend the next 50 minutes, I'll try and keep it to 50 minutes, discussing this issue here, why I think the emperor is streaking in front of us naked, while most of us are sort of saying, aren't they beautifully attired, including many scientists. I think actually if you stand up and say the climate change emperor is naked, most people will shut you down. They do not want to hear that, however obvious it may be. So I think as an analogy, it really works quite well. So it's real close to the emperor, trying to think what do we need to do to ensure that the emperor can stay warm, or cool perhaps in a climate change world. So discussing this in relation to climate change. I want to set a context up to start off with for this. This is a, can you all see the screen okay? So okay, slightly lopsided, but yeah, just move a bit. Right, so this is from that well-known left-wing think tank, the International Energy Agency. So this is from their chief economist. So this is the conventional wisdom here. We're on track for a 3.5 degrees C temperature rise by 2040, and they're looking at that compared with today, so compared with pre-industrial times, that's a 4 degrees C or so rise by around the middle of the century. That's what we're on track for at the moment, according to the IEA. When Fatih Birol looks at this data, the trend is perfectly in line with a temperature increase of 6 degrees Celsius by the end of the century, that is, which would be have devastating consequences for the planet. So the IEA are saying we're heading towards a 6 degrees C future, 6 degrees C global mean surface temperature rise. Today, I think it was today or yesterday, PwC, PricewaterhouseCoopers, put out a report where they're saying also that we're online for 6 degrees C. I mean, I have to say, I think it's been pretty obvious the last 10 years. That's where we're pointing towards. But it is interesting to see orthodox organisations coming out and saying this now. Birol went on to say we have 5 years to change the energy system or have it changed. So it will either be changed by the climate and by the environment around us, or we can actually start to change it. Now, note it says energy system. It's not just about supply. So real credit here to the IEA for thinking about this quite differently, prepared to stand up and say things that many of us would not agree with. The Copenhagen Accord, hopefully most of you are familiar with this, is what we signed up to, including most nations around the world have signed up to this, and in fact it was broadly followed by the Cancun Agreement. Now, they're not legally binding, but like all international agreements, they're never really legally binding. But this is interesting, because I think it actually says something quite important about how we see climate change. To hold the increase in global temperature below 2 degrees Celsius, notice below, not a 50-50 chance of, below 2 degrees Celsius, and take action to meet this objective, consistent with the science, that's quite radical, and on the basis of equity, even more radical. And most nations have signed up to this. So I think we should always hold our leaders to account. Hold that in front of them and point out what it says. Science, equity, and that we stay below 2 degrees C, not a 50-50 chance of it. So how consistent are these 2, 4, 6 degree futures with where we're actually going on the emission trends? Now, there are a lot of graphs in this, and I was told that graphs are a good thing by some people and bad by others. So unfortunately, I quite like graphs. Hopefully you can see this here. It doesn't matter too much if you pick up the numbers, but this is basically CO2 in billions of tons up here, and this is going from 2080 out to 2050 at the bottom. Now, all I'm going to plot here is what's happening to emissions. Now, the Intergovernmental Panel on Climate Change, the big UN body looking at these issues, was set up in '88. The first report was 1990. So these are emissions here in 1980. That's the report set up, the organisation set up here, which is the main body that pulls together the science from around the world looking at these sets of issues. The first report, 1990. The Rio Earth Summit, 1992, that some of you here with the same colour hair as me will remember, or those with no hair probably can remember as well. And the second report came out, I think it was in 97 from the IPCC, Intergovernmental Panel on Climate Change. The Royal Commission report that laid the foundation for the 60% reduction in emissions by 2050 for the UK. The Royal Commission report came out in 2000. The third report came out in 2001 from the IPCC. Look what's happening to emissions during all this time. Emissions just keep rising. The most dangerous threat, climate change is the most dangerous threat, that's the quote from the previous chief scientist, David King, 2004. The fourth report from the IPCC, 2007. The Copenhagen event in Copenhagen in 2010. Look at the emissions now, heading up towards double what they were in 1980. Then the Rio Plus 20 event this year. Now we've had all of these events, all the great and the good flying around the world. We've had pop concerts, we've had all sorts of nonsense about climate change. And all that has happened, what a surprise, is that emissions just keep rising and rising. Yeah, that is the backdrop, that's the context against which we've got to filter this in. Now remember that globalisation is quite a new phenomenon. I don't think we've really got globalisation yet. Well, I might say thankfully. So we had the groundwork for globalisation that sort of led up to 2000, but pretty much the OECD fed its own desires up until 2000 for manufactured goods anyway. More recently, we've seen China actually actively engage in the process of globalization. So this is the first time, I would argue, we've actually got a globalized world with mass transport of traded goods around the world. And it's really only China, and one or two maybe South Korea and so forth, but lots of parts of the world are not involved in that. India's not really involved in it, African continent is hardly involved in it. So it's quite new. And then we had the economic downturn here. Now, it's worth noting the economic downturn. In 2009 to 10, global emissions went up by 5.9%. That was at the start of the economic downturn, 5.9%. I think that's higher than at any point during the Industrial Revolution. And even the following 2 years, with 2010 to 11, went up by about 3.2%, and this year probably a little bit below 3%, maybe 2.6%. We haven't got the final data on that yet. But despite the economic downturn, we're still seeing emissions rise, keep going up and up at the moment. So what are the future for emissions? Well, let's just think about the energy system. And most of my work and most of what I'm going to talk about today relates to energy. If we build a power station, if we build oil rigs, gas platforms, which I used to work on, they generally last for 25 to 50 years if they're reasonably well built. If we build infrastructures, this building itself, grid networks, pipeworks, sewage systems, those sorts of things, road networks, train networks, they're going to last for 30 to 100 years. So once you put them in place, that's typically how long you expect to see them live. If you build an aircraft and sell it, or a ship, you normally expect to see that living for operating for about 30 years. So these things really lock you in to the future of the next numerous decades. So if we think about those supply network, and remember, most of the world now is fitting that like there's no tomorrow, and we're not changing ours, we're living with what we've got and just modifying it a little bit. But the rest of the world is trying to build this as fast as possible. China at the moment is building about 150 international airports, which we can't blame the Chinese because we'll be flying in and out of them, no doubt. So 150 international airports. If they flew as much as we did, they'd require 450. Most of that for academics, I think. So let's just think now about some economic assumptions. Let's imagine that the economic downturn stops by 2015. Maybe that's optimistic, I don't know. Let's imagine in the wealthy parts of the world, the OECD, that our emissions reduce from 2012 from now onwards. In fact, they're roughly stabilising as it is, not through judicious climate change policy, basically because we've either had a recession or because we've exported the emissions elsewhere. China emissions, let's imagine they follow their 5-year plan. Let's imagine there's some sort of stabilisation in fossil fuel prices. We've seen that in the States. Their gas prices have dropped almost by 80%. That may or not carry on. That's due to shale gas. Let's imagine that India and Africa join in with globalisation sometime in the next decade. And that China peaks its emissions by 2030, so China emissions stop going up by 2030, that India peaks by, say, 2045, Africa by 2060. You start to plot what that would look like, and it looks something like that. Now, what's interesting with that is that, quite a few people I've spoken to about this, so this is actually quite optimistic, but they never work the area under the curve. The area under the curve there, which is what really matters, these cumulative emissions, relates to about 5 gigatons, 5 billion tons of CO2 for them that are interested. Sorry, that's completely wrong. That's, say, 5,000, that's a bit in there, isn't it? Out by a factor of 1,000, almost like an economist. So let's just say 5,000 gigatons, not 5. And that's somewhere in the region of 4 to 6 degree temperature rise by the end of the century. But we have to bear in mind that when we start talking about these higher temperatures, the science is very uncertain because there's a lot of other feedback issues there, a lot of non-linearities that are very complicated to understand. Probably you can't fully understand them at any point. But it looks that, in the orthodox way of thinking of these issues, this is a very, very high temperature future. That's where we're heading to at the moment. Just out of interest, that's the 2 degrees C we've signed up to. So that's what we have to do for 2 degrees C, and that's the gap between, the void between the rhetoric, here we are, rhetoric, and it's some reality. There's another couple of bits I put on that. Just it's interesting that you can't, this is the supply bit, you can probably do something about supply, about energy supply within, say, 2025, 2030, 2040. You probably can't do anything about it this afternoon or in the next 5 or 10 years. Not significant. But you can do a lot about the demand side. So the argument we make repeatedly is that actually it's demand that really matters. And actually it's demand that brings the issue down to the local level. Because it's us, it's what we do that demands the energy. The supply side typically is a much more centralised issue and probably can't get away from that completely, whatever we do. And most demand technologies actually can change in 1 to 10 years. Most car journeys are travelled by cars that are under 8 years old, 90% pretty much of all vehicle kilometres. And behaviours, of course, can change instantly. We can change our behaviour now if we wanted to. We can switch all this off and go home if we wanted to do that. Or perhaps we're better off being here and having the heating off at home. That's probably better for collective heat. So now I want to think a bit about the undergarments of the emperor. Why is it that the orthodox view is holding that at least they've got some underpants on. This is from the Avoid project. This is a 2009 Avoid project, which is a major government initiative with a lot of people involved with it, including some colleagues of mine in the Tyndall Centre. And the latest one is out, which I've not put the quote up from, but it's very similar. It is possible to restrict warming to 2 degrees C with at least a 50% probability, with emissions peaking in 2016. Don't hide that point. The global emissions peaking in 2016. That's 1 year after Stern suggested. And a rate of reduction of 4% per annum thereafter. So basically very optimistic, upbeat. This is the Committee on Climate Change. To keep global average temperature rise close to 2 degrees C, the UK must reduce by 80%, blah, blah, blah. But this bit, the good news, this is to keep it, well, maybe they believed it, but I can't believe it. I can't think it's really the case. The good news is that reductions of that size are possible without sacrificing the benefits of economic growth and rising prosperity. Because we mustn't, whatever we do, question the astrologists. I'll be using that term instead of economists as we go through this. I particularly mean a particular group of economists, so not all of you. So if any of you economists are not neoclassicals, then I don't put you in that group. And then this is from the Adam and Hume report, European report 2010, a low stabilisation target of 400 ppmv CO2e, in other words, lower than we have today, can be achieved at moderate cost and a high likelihood of achieving this goal if you own a TARDIS. But, so these are important government reports. And people are saying these sort of things. But they still look naked to me. I can't see any pants on the streaking emperor. So the alternative take that my colleague Alice Bowes and I have put out in a paper in 2008, I should say there, and indeed is in keeping with the IEA views today and the PwC views on this, it's difficult to envisage anything other than a planned economic recession. We were told that's too negative a term. We should have used the word contraction. But I think most people know what we mean. And being compatible with stabilisation at or below 650 parts per million CO2e, which is about 4 degrees C, there or thereabouts. So that's what we wrote in 2008, and then we revamped the analysis in 2011 for looking at the poorer parts of the world and the wealthy parts. And if you're going to peak emissions globally by 2015 to 2016, which is where most analysis peaks emissions, this would require a prolonged period of austerity for Annex 1 nations, for the wealthy parts of the world. And that's not pulled out anywhere. Everyone always talks about win-win opportunities, green growth opportunities, all these wonderful expressions that are completely meaningless when you think about the curves I showed you at the beginning. It would also be quite a change in the development patterns for the poorer part, the non-Annex 1 parts of the world. For those who aren't familiar, I'll use this term quite a lot. Annex 1 nations, they're not quite OECD, but they're broadly OECD wealthy nations of the world. So it includes, obviously, Europe, the US, Japan, Russia, so that sort of suite of nations. And then there's the non-Annex 1 nations, which are all of the others, and does include India and China. It's a better split than global, but it's still very, very rough coarse level of language. But they commonly use Annex 1 and non-Annex 1 in the climate change negotiations. So do climate scientists take any, and scientists, I'm really talking here about the people that work on the cusp between science and policy, people like myself, but also a lot of other people in the Hadley Centre and elsewhere who don't necessarily get engaged with the really nitty-gritty of the science in the lab or empirically outside, but they are involved in translating that into emission scenarios and then feeding that into policymakers. They're the particular group I'm talking about here. So do we, as climate scientists, take any responsibility for this streaking emperor? Inconsistency in 2 degrees C. Now notice this, the Copenhagen Accord, hold below 2 degrees. The low carbon transition plan must rise no more than 2 degrees, that's the UK plan for this, must rise no more than. The EU, we repeatedly see documents that do not exceed by more than 2 degrees, that sort of language, not more than. Now if you look at the IPCC, they're very clear about this, that if you have language like this would go along with the very unlikely to exceptionally unlikely to exceed 2 degrees C. They use a form of language which they then very conveniently translate that into a percentage probability. Now this is important because it tells you about how fast you've got to reduce your emissions, how fast you've got to come off the curve. So what we're broadly saying here is the sort of language we use would say about, you might accept a 10% chance of exceeding 2 degrees C. Remember, 2 degrees C is this threshold between acceptable and dangerous. That's not a scientific decision. It's a political, civil society, international fudge, like all of these things always are, of course. People coming together, it's informed by science, but it's not a scientific decision that 2 degrees C is the appropriate or not the appropriate threshold. We have come collectively together, whether we like it or not, and come up with that as the appropriate threshold, 2 degrees C. And above that we say is dangerous. So if you think of the busiest road in Bristol, and at the moment we're going for 50-50, which is what most legislation is built on at best. That's every second time you cross the road, you close your eyes. That's what we're aiming for. I mean, it'd be quite good for the emissions because it would bring the curve down quite quickly. So there are merits to it. But anyway, so 10% chance. Now, Despite this, the Committee on Climate Change, they're most optimistic. The UK government has a Committee on Climate Change, for those who aren't aware of this. It's said to be an independent committee. It's not really an independent committee, to be honest, but it is an important committee, and all credit to the UK government for establishing this, and all credit to the CCC. They do some very, very good work. I still think they very much sweeten the pill, far too sweet in my view. The Committee on Climate Change, their best budget is for 56% chance of exceeding 2 degrees C. So that's their best one. And the UK government adopted their not quite so optimistic one of a 63% chance of exceeding 2 degrees C. So we're all signed up to hold to 2 degrees C, but our policies have been put in place for a really high chance of exceeding that target. And actually, for our national policies, we're being very, very unfair to the poorer parts of the world in terms of issues like deforestation and so forth. That should be we should have a much, much tighter constraint on that for the UK. If you want to ask me about that later, you can do. But we're being very unfair on some other parts of the world in making that decision. The argument to make is, can that 60-odd% chance of exceeding 2 degrees C, can that be reconciled with hold the temperature to below 2 degrees C, take action on the basis of science? Of course it can't. And yet scientists say nothing about it. Our job as scientists is to stand up and say, hang on, that doesn't really fit. But we have repeatedly, I'll make this point right through the talk, the scientists repeatedly stay quiet. Like old Thomas More's maxim, silence is consent. In other words, we stay quiet because we're trying to keep our paymasters happy. By staying quiet, we agree with what's going on. So that process of consent, I think, is really quite invidious in the whole climate change story. So what we've now, that's at least there's some scientific framing for that, but let's think about this a bit further. What else have we typically seen? We see these sort of things all the time. Large reductions in emissions, 80% by 2050, by not in my term of office, by I'll hand the problem on to my children. I'll have left being the CEO of the company by then. So we all like this. It's big reductions, big, great, grand schemes for somewhere a long way away when we'll either be dead or retired. So this is something we all like. It has no premise in science. And yet scientists have repeatedly used this language and do not criticize it. They still repeatedly use it. One of the major funding councils for universities, the Scientific Funding Council, if you like, the EPSRC, uses this for overarching for its energy research. It has no premise on science, but it does fit with the policymakers' demands. The CO2 from this event is in the atmosphere for 100, 200 years, roughly. Keep these projectors on, the lights on. So we are changing the climate tonight. Whatever else we may do, we are changing the climate as we sit here now, using fossil fuels to do this talk. 2050 targets, therefore, are irrelevant. It doesn't matter about what happens in 2050. It's about what happens today, what happens tomorrow, really what happened in the past as well, but we can't do much about that. So it's about the build-up of carbon dioxide in the atmosphere and other greenhouse gases. And that's really important. What matters are the cumulative emissions, the build-up of emissions day in, day out. That's what's important for climate change. Not some long-term mythical target that's got nothing to do with science or climate change that keeps us all happy. So we have to move back towards cumulative emissions, carbon budgets. But that rewrites the chronology, it rewrites the timeline of climate change, takes it away from wind turbines in 2030 or nuclear power, carbon capture and storage, other great schemes way off in the future. That these things are no longer adequate. What it tells you is you've got to do something immediately, urgent and radical reductions. You've got to come off the curve now. And you can't come off the curve with supply technologies, not quickly enough. Now, I want to be quite explicit here. I'm not saying the supply side is not important, but it cannot get you off the curve anywhere near fast enough. So you'll have much higher temperatures if we just rely on people like me, engineers, to come up with technologies that will solve the problem in 2025 or 2030. And remember, it's not just coming up with the technology, it's getting that technology to penetrate the energy system. And that can take decades. So it's not just having the good idea, it's making the good idea actually work. So how does this scientifically credible way of thinking of 2 degrees C, this idea of carbon budgets, how does that reframe the whole debate? Well, firstly, let's look at the latest data. It's not quite the latest data, and we can plot this for next year. It'll be worse next year, and it'll be worse the year after. So we all know this. And actually, this curve could be for anything to do with humans, really, including arrogance. That always seems to go up exponentially. So we have emissions of carbon dioxide here, and we have this from the pre-industrial period here, back in the 1750, 26 years before Adam Smith, Wealth of Nations, up to today. And what we see is the rising curve. And that could be plasma screen ownership, it could be how many vehicle kilometres we travel, how many people are on the planet, how big our houses are, all the rest of it. Whatever it is, it's like that, shaped like that, really. The growth rate in CO2 for the last century was 2.7% per year. On average, was 2.7%. Now, remember, that's a century when we didn't think about climate change, and the growth rate was 2.7. From 2000 to 2007, the growth rate was 3.5%. Remember, it's a growth rate of a bigger number as well. That's why it's exponential. So despite the fact we've been rambling on about climate change repeatedly, the rate of growth of CO2 has actually gone up, not down. And instead it was 5.9% in 2009 to 2010, dropped a little bit now. Now what's interesting on top of that, it's really just pointing completely the wrong direction, exactly the opposite of the direction that we should be going in. This may not mean much to many of you, but just to say that the models that we have a whole set of models about what might happen to the emissions in the future. And the highest set that we consider we did used to consider till quite recently, was appropriate for the future. Had a growth rate out to 2020. The scenarios go right the way up to the 2100, but their short-term growth rate was only 2.2%. So the highest ones that we model, and we didn't ever fully model those, we used lower ones at about 1 to 1.5%, weren't even in keeping with what the emissions that we were doing at the time were pointing in the direction they were pointing in. So we've always underplayed everything we possibly can. We've done exactly what the skeptics said, but in reverse. We've underplayed at every single occasion what we can do on climate change. And I'm particularly talking here about the scientists engaging with the emission scenarios, so not the other ones that do the more detailed bits of work that are really important behind all of this. So what does our abject failure to reduce our emissions and this idea of cumulative emissions together, what do they say about the 2 degrees C pathways? If anyone wants the papers for this, I can either pick them up on the web because we made them open access, or I can send them to Philip or someone of the organisers. You can get to see the papers if you want. Basically, the earlier you can peak the emissions, the earlier you can bring the emissions to a head and then bring them down, the lower the reduction rate has to be after the peak. By and large, there's a few caveats in that. If we peaked emissions, these are roughly a 50-50 chance of 2 degrees C, there or thereabouts. If we peaked emissions by 2015, then many of you here heard of the Stern report? Quite an influential report. I don't know if you know, but the Stern report is premised on global emissions peaking in 2015. He didn't speak to Africa, India, China, anyone else like that. I'm sure he spoke to a few folk in Oxford. But and that is very typical. We take a very parochial view of the world. It used to be our world, but it's not really anymore. So 2015 peak. Now, this is our emissions here, and probably a few of you struggle to see this. These are our emissions going up here to this peak in 2015, then coming off. And then this bit here, you can never get emissions down to zero because you've got to feed the population. And feeding the population, as far as we can tell, you won't get the emissions down to zero because even just ploughing a field will release methane into the atmosphere. Fertilizer will put you N2O in the atmosphere. So there's all sorts of things to do with agriculture. Even if you make it very efficient, you're still going to have to get emissions. Remember, it's the area under the curve that matters. And there's a range of plots here, a range of curves that are drawn, and that's because science, as all good science is quite uncertain. So we plotted the range that we used, and this is from the AR4 report, for those that are interested. Now, if you peak in 2020, what you'll notice, you peak a bit later, but your emissions start to come down a bit faster, and if you peak in 2025, it's like lemmings off a cliff. And if most of you think about when do you think global emissions are going to peak, if you think about it yourself, you probably think it'll be, well, here or later. So this is, remember, for a 50-50 chance of crossing the road safely in Bristol. 50-50 chance of dangerous climate change. So if we take the one in the middle now, the 2021, and I'm going to strip out from that, because that was emissions of all sorts. I'm going to strip out deforestation emissions, I'm going to strip out the food emissions, and I'm pretty much going to leave us just with what's left for energy, the area that I focus on. Already, by 2012, in fact by 2010, we'd blown the budget. If we think of what the emissions are from deforestation over the century, we think of feeding 9 billion people, or 7 to 9 billion people over the century. If you think of the emissions we put out between 2000 and 2010, we have no emissions left for energy for most of the scenarios. So we have to be on the optimistic end of the science. And if you then plotted that, and it's not quite come out, for some reason it's not worked out there, but anyway, if you then plot that, what you'll see, the energy emissions have to go down to zero. Now that's interesting, because if the emissions go down to zero, you can't have any carbon capture and storage, and all these great schemes that are out there to try and take the CO2 out of coal or gas-fired power stations, because you cannot get them down to zero. You can't get them near to zero. Probably somewhere between a 60 and 85% capture rate. In other words, 60 to 85% of the carbon dioxide going up the flue or in the fuel in the first place, you can strip out. But you're always going to get something, a 10%, a 15% residue. And you also, of course, are going to have to get a lot more of it mined out of the ground because it makes the process a lot more inefficient. And as you mine coal or as you get gas, you will always get releases of hydrocarbon gases into the atmosphere, and you cannot stop that process. So you can't use carbon capture and storage. So all you can fit in this are, when you think about it, are your biofuels, which have a lot of problems with them, your renewables, and nuclear. And they're all very low carbon, very low to zero carbon, as near as damn it. So it says a lot about what you have to do. By 2035 to 2040, around the globe, your cars, your planes, your fridges, everything, no carbon. Remember, this is a global plot, not for the wealthy parts of the world. So I now want to think about that. What does this mean for the wealthy parts of the world, the OECD countries, the Annex 1 countries? Well, firstly, I think it's fair that we think about what could the non-Annex 1, India, China, continent of Africa, some of the other poor parts of the world, what could they do? This is from our later paper in 2011, published by the Royal Society. If we think about the emissions from the poor parts of the world, that's the emissions now going up, keep going up here, and I made an assumption here that they peak, well, they grow at 3.5% per annum. That's growing lower than they are today. They probably grow at something like 4.5% to 5% per annum for the poor parts of the world. So we're already saying to the poorer parts of the world, please don't grow your emissions as fast. And they say, no problem, we'll cut back just for you. So they peak emissions in 2025. I don't think any country in the non-Annex 1 part thinks that's viable, including the Chinese. But let's imagine we can persuade them through logic, argument, and actually good examples that we're doing at home here, that they'll peak their emissions in 2025. Then they'll come off the curve at twice the rate that Stern says is possible with economic growth. In fact, twice the rate that pretty much all economists will tell you is possible with economic growth. So then you say, well, we now know what that looks like. That's a pretty ambitious curve to ask the poor parts of the world to do that. Remember, this is where most people in the world live as well. And the area under the curve is what matters. So you then know the area under the curve, you know how much budget you've got for 2 degrees C for the globe. You say, well, what's left for us? What's left in the wealthy parts of the world? Well, it doesn't look very attractive. Those of you who can't see, it's a vertical drop-off from 2010. There's nothing left for this is a 40% chance of exceeding 2 degrees C, roughly 50-50 thereabouts. There's nothing left for us. If we asked the poor parts of the world to really pull out all stops, we would have to stop putting any emissions out in at least 2010 to give us an outside chance of avoiding what we've defined internationally as dangerous climate change, that we've all signed up to, that we pass international negotiations on, that we pass our own domestic legislation on. We never even bother thinking about any of this, and the scientists stay quiet. That's a peak in 2010, coming down. I mean, I like engineering. I think you do a lot. As an engineer, given a good spec, you can produce a lot, but you can't have an infinite rate of reduction. And in this case, it'd be even more than that, because you've got to do it in the past. So they almost succeeded that recently with that neutrino experiment, but I gather it didn't work. So how come this, I would argue this is completely premised on Hadley Centre type analysis. All the standard science feeds into this. We're not using any tipping point issues, no discontinuities. It's all the standard analysis that feeds into everyone else's sets of emission scenarios. So why is it we've come to such fundamentally different conclusions? I'm going to think about this graphically, and it's actually quite important, this, I think, to get a handle on how much we've deliberately twisted the debate. All right. Another graph. I'm not sure. Do you say graph down here? I'm not sure what you're saying. Where I am, it's a graph. So we've got CO2 up the side, and we've got the century, 2000 to 2100 out the bottom. It doesn't matter much. It's just a really symbolic curve, really. First things, what are the current emissions? We're asking now, why is it our analysis is so different? What growth rate do we assume will occur globally until we hit a peak? When do we think that peak in emissions will arise? What reductions are there after the peak? What is viable there? What's the emissions floor? In other words, how much emissions related to food is in there? Can we suck the CO2 out of the air with some magic? And I don't think it's necessarily magic, but I think at the moment it's certainly in the Dr. Strangelove category. What emissions are there for 2 degrees C? What budgets are we going to use for 2 degrees C? Because there's a lot of scientific uncertainty there. So let's just quickly look at those. Remember, what I'm trying to say here is the scientific community repeatedly underplays the story. That's what I'm trying to show here. It's very unpopular with some of my colleagues. The Stern report, for those of you who are familiar with, looking at current rates. Now, the Stern report was published in 2006. So he had the data up to 2006, including his researchers, and it wasn't without a few pounds in writing the report. And I have a lot of time for the report, except for the numbers. But I like the ethos around discounting, I think, was really important. And it got mostly criticised for that by the economists. But in terms of these numbers, he had the growth rate of CO2e at 0.95% per annum from 2000 to 2006. Think about that, that's that angle of the curve going up. But the real data was 2.4% per annum. That's a massive difference. Now, that's not a difference in the prediction. That data was available and was collected by governments and submitted to the United Nations Framework Convention on Climate Change and CIDIAC and all the other great people who collect this data. Anyone could have got the data off the web for nothing. But instead, we use the 0.95% per annum. And actually, loads of climate models, emission models, have just done this. They continually use an extrapolation of 1990 optimistic trends. They don't bother checking the real data. And the scientists say nothing. So an area of 250%. And that would fundamentally change the subsequent analysis in the Stern report. And what does the scientific community say? Absolutely nothing. Just stay quiet. Now, just to put you this annoyed me a lot of the time, and that's quite old, 2006, but just to give some idea of this, that's the growth rate he assumed out to 2000 to 2006. That was the real growth rate. Now, imagine you just extrapolate that, because that's what you do with curves. You think, well, where's it gone? Where might it go? So let's just extrapolate it out to 2020. And you already start to see a massive gap between the two. And of course, 0.95% hasn't been what's happened, nor is 2.4. It's actually been going like this. In reality, much, much faster. So to start off with, we've not even got the current rate of emission growth correct, deliberately so. I think that's fair to say. Allegedly, deliberately so. Just protect myself. I quite fancy an open prison, no admin and access to the internet. Lots of research. So, right, what growth rate, we've now talked about the current emissions, what growth rate out to the peak do we see? There almost every single analysis shows the growth rate to the peak emissions of 1 to 2% per annum, despite the fact it's been somewhere between 3 and 6. The latest analysis just to come out from the Avoid project, same sort of thing, relative, well, slightly higher, but I think it's low, I think somewhere between 2 and 3. But basically, all analyses out there are way below those that we're actually seeing. When did emissions peak? This is quite interesting, isn't it? That almost all analysis, if you look at the details, look at the spreadsheets that they give you, not necessarily the graphs, look at the spreadsheets, they'll peak between 2014 and 2016. In other words, they're taking as their assumption, which they feed back to policymakers, their conclusions, that global emissions will peak between 2014, 2 years from now, and 2016, 4 years from now. Remember, the Committee on Climate Change, the UK government's Committee on Climate Change, goes for 6 to 2016. Stern, 2006, assumed a 2015 peak. Eldon 2015, CCC used a 2016 peak, which means that China and India have to peak in 2017. The Adam report, European report, same thing again. So what we see is a lot of reports assuming at 2014 and 2016 global peak. Everyone knows that's not going to happen, including all the people that write these reports. But that's not the worst of it. The fact is there are lots of analyses that peaked their emissions in 2010. Bayer 2006, the United States Climate Change Science Program 2007, that's when it came out. So these are when it came out, and they're assuming a 2010 peak. Ackerman, report came out in 2009, had global emissions peak in 2010. We contacted them about this. We didn't get a particularly satisfactory email. The Hume report came out in 2010, had emissions peak in 2010. But that's challenging. Peaking in the past. And I say the neutrino didn't work. Peaking in the past. Hansen, 2008 report, had emissions peak in 2005 in that report. Nordhaus, and these are sort of two ends of the spectrum on climate change, 2010 report had emissions peak in 2005. Now, if they were abstract analysis, fine, but what they then do is they then give policy recommendations on the back of those. Look at those reports, you'll see policy recommendations. So a policy recommendation premised on owning a TARDIS, and then this is what we then develop our policies from. This happens repeatedly. What do the scientists say? Nothing. So that's the peaks. What about the reduction rates? Well, these are, we come back to our old friends, the astrologists. These are held in check by what economists tell us can be matched with economic growth. I mean, given the economists haven't really been very good at understanding the sort of economic chaos that we're seeing at the moment, I think it's odd that we actually take too much notice of what they say about the future. But here, there was almost every single curve out there, that reduction rate is constrained at 2 to 4% per annum. And that's because anything outside of that, the economists tell us, cannot be compatible with economic growth. So it doesn't matter if we wipe the planet out, if we all die, as long as we're not interfering with economic growth. So this bit here completely constrains the rest of the analysis. This is why you have to massage this bit and why you have to muck around down here, because the economists have told you that, and we daren't question them. The Osborns of this world, the Vince Cables of this world, with their wonderful intellect. We have to take every note of what they have to say. And then the emissions floor. In fact, I'll go through this quickly. This is just a difficult issue to understand because people have done their best on this, and it's quite challenging to know what that's going to look like. I don't think there's been anyone trying to manipulate this really at the moment. But there's an emissions floor here, which I won't go into, but say relates to food production. If someone wants to ask about that later, they can do. But the bit that we do manipulate is that most analysis out there now, low carbon analysis, assumes we can suck the CO2 out of the air. So they almost all have geoengineering in there, negative emissions technologies. And almost without exception, what they mean is actually grow biomass, combust it in a power station, and then put the gas back underground, the carbon dioxide underground. They pretty much all have that in there. So they're sucking the CO2 out of the air, or large numbers of them. And that's used in report after report. They use the negative emissions in there. So ubiquitous in low carbon scenarios that we use geoengineering. We've never succeeded in geoengineering at any scale. So we're putting something in place that we assume will work, and I'll come back to that in a minute. Then the other thing is, what size of the budget do we use? Well, the Hadley Centre, the UK's premier modelling centre in this area, and one of the leading model groups in the world. For around about 2 degrees C future, they gave to the IPCC, they gave a figure of 1,400 billion tonnes of carbon that we could dump in the atmosphere over the century. The Committee on Climate Change and the government's choice is to go for 2,900 gigatons. Just look at the difference. One's almost twice as high as the other. So we're also changing what area under the curve we can use by changing those probabilities. So little tweaks here and there allow you to all sorts of ways to massage what you're doing. Now, the other bit I want to talk about briefly, and I think this is really quite worrying, this is the split between the poor parts and the wealthy parts of the world. So if you imagine that the wealthy parts of the world are doing this, and the poor parts of the world, their emissions have been doing this. And the point is, when do they cross? When they cross is a really important point. The United States Climate Change Science Programme, this is the language it used this is a really important document in the States. We have something similar in the UK. Used meaningful and plausible, that's their quote, reference scenarios from a prospectus of highly regarded integrated assessment models, which basically is when scientists come together with economists and produce something that's expensive. I am, at the moment, very unconvinced that they have any. I think they're actually more dangerous than any good they provide. So these meaningful and plausible scenarios from highly respected modelers, they assumed that non-Annex 1 emissions would exceed Annex 1. In other words, the poor parts of the world, their emissions would be higher than the wealthy parts of the world in 2013, in Stanford at 2021, and in the MERS model at MIT. These are not minor institutions in 2023. The real date was 2006. Don't let the empirical data get in the way of a good story. So the empirical data that we have, they crossed over in 2006. Notice this report came out in 2007, and these great modelers here assumed it happened way in the future, because it allows you to do a lot more about giving more emission space to the wealthy. So, this is supposed to be science, remember. Now, meaningful and plausible, I don't think so. United Kingdom's Climate Change Committee on Climate Change, their budgets, they use the word feasible 40-odd times in their 2009 report, and something similar in their more recent reports, and yet it has global emissions peak in 2016. Do any of you think that's feasible? None of them do, but they use the word feasible repeatedly, because it portrays a language that makes it sound feasible. They had Annex 1 emissions peaking in 2007 to 2010. That doesn't necessarily seem too unreasonable, and they assumed that poor parts of the world would peak by 2018, and China and India would peak by about 2017. So that's not in any way feasible in my view, and yet that's what we are basing our analysis on in the UK for our climate change policy. So across the board, I would say that we are underplaying these issues. I'm not going to go these in any detail here. All I'm saying here is that the geoengineering issue is really important. Now, not to say that we can't do it, but we haven't done it. We have very few pilots that are even moving anywhere near this direction at the moment. And the one that pretty much everyone uses is biomass and carbon capture and storage. You grow the plants, you burn it in the power station, and then you take the flue gases out and you put them deep in some reservoir somewhere, an old gas reservoir or an oil reservoir. It's worth noting there's not one large-scale carbon capture and storage power station in the world. There's some moderate-sized ones, well, hardly moderate, some small plants around the world now. There's nothing large anywhere on the planet at the moment. There are big issues about food and biodiversity with biomass. So we're going to be growing this biomass. If you look at shipping, it thinks it's going to use biomass. The car industry thinks it's going to use biomass. The aviation industry thinks it's going to use biomass. The power sector thinks it's going to use biomass. And we're going to use biomass here as well to put underground. Everyone's thinking they're using it. And every biomass plant, every biomass scenario out there has a lot of coal CCS. Is there enough space out there to put all this carbon dioxide is a reasonable question to ask. So that's that. The nuclear one's interesting as well. And I'm agnostic about nuclear. I'm not a great fan of it for the UK because we've got plenty of renewables, but for some poor parts of the world, maybe Iran being one of them, they could actually think about a low carbon fuel. But we're awash with renewables in the UK, so we don't require to have it here. So look at these integrated assessment models. Virtually every single one of them has a massive increase in the supply of nuclear power. And yet you then start to say, well, have they thought about the access to uranium-235? Now, there's uncertainty around that. Some people say there's quite a lot left. Other people say, well, we'd have less than 40 years if we started to ramp up that supply system. So 235 is really important. Is there enough there? Those questions are not being asked appropriately. We can go to fast breeder reactors, which we do not have a fuel constraint, but there are lots of issues around fast breeder reactors that make them very, very unpopular for lots of good reasons and lots of bad reasons why they're unpopular. But these are questions that are not being asked. We may think about thorium. People say, well, thorium will help, but we haven't got thorium reactors. Thorium might work for the future, but it's not going to work in the next 10, 20 years, not in large-scale rollout of the technologies. And yet these are just assumed to be occurring in the scenarios, that we're just rolling these things out. Scenarios are supposed to be an exploration of plausible futures. But they're not, they're hardwired. These are hardwired to the assumptions. What we're doing is we're pretending we're exploring the future and we're just hardwiring them depending on what our paymasters tell us, broadly. And I think that is not the way that science should be done. And let me be quite specific about that. I'm talking about the people doing the emissions modelling here, not about most of the scientists who work on climate change, but that particular group, the group that I engage with, and I'm one of. So I want to know, what was I doing here? Oh yeah, I'm trying to understand, what was my previous slide here? Yeah, I'm trying to understand why this is happening actually now. So with few exceptions, the scenarios out there, they hide or they massage historical emissions. So they change the framing of where we are today. That happens repeatedly. They always underestimate short-term growth out to the peak in emissions. That happens, again, pretty much with every scenario out there. The peak choice is Machiavellian at best. No one thinks we're going to peak in 2016, and yet virtually every model will peak in 2016, because that gives you a nice answer for your policymaker. The reduction rates are dictated by the astrologists, so you're just told what you've got to come off the curve at. Geoengineering is assumed to work. I'm not saying it won't work, but we should have scenarios that some include it, that some don't, and probably only very few of them should include it. The split between the poor and the wealthy parts, annexed one and non-annexed one, is pretty much either neglected or hidden. Great big assumptions about big technologies. And as someone who used to work offshore, I like big technologies, but they're not quick to roll out, and they're not like they are in the textbooks. So you don't get the efficiencies they give you, tell you in the textbooks. You know, the real world of big technology is very different from the textbook world. And actually, the economists have nothing to add to this, not the neoclassicals, because this is a non-marginal world. This is a world where we are changing things so rapidly at such fast rates. The theories that most neoclassical economists do, market economists use, are based on marginal analysis. So it would be like using Newton to understand subatomic particles. You would not apply the theories of neoclassical marginal analysis, market analysis, to understand step change issues that we're talking about here. You wouldn't apply Newton to understand subatomic particles. And yet we continually do that. There's a real arrogance in that. And we also still think, we have a magician's view, as I say, of time here. We think the bull can meander into the china shop, trash everything around it, come out, and we're one doing with some super glue, and it look just like it did before. That's what we think about the planet, that we somehow can do all this, reverse ourselves out of it, and then fix it, which is quite an arrogant position to take and doesn't fit with any of the science that we know around these issues. So why is all this the case? Why have we got this political creed around 2 degrees C? These are some quotes. I'm putting these into paper, and I informed the people that I've used these quotes. I haven't said who they're from. This is a very senior colleague of mine. I have a lot of time for him. Very senior political scientist, advises the government a lot of the time. I spoke to him in 2010 after an event, which was all about 2 degrees C stuff. And he said, too much has been invested in 2 degrees C for us to say it is not possible. It would undermine all that's been achieved. It'd give a sense of hopelessness that we may as well just give in. These are the exact words. This is my asking the question then, are you suggesting we have to lie about our research findings? Well, perhaps just be not so honest, more dishonest. Yeah. So that's from a political scientist who really understands this terrain of climate change policy and science. This is a senior government advisor who won't say who it is. We can't tell them, ministers and politicians, it's impossible. We can say it's a stretch and ambitious, but with political will, 2 degrees C is still feasible. Even when they're probably at 3 and 4 degrees C and swimming around in sea level rise, we can still tell the ministers 2 degrees C is possible. He actually said that in a public place, so I won't. I could name him, but I won't. Right, that's the Department of Energy and Climate Change. That's Ed Miliband. The day before he went to Copenhagen, I had a 20-minute meeting with him in Manchester before he got the ferry the following day. I'm not sure it was the ferry, but anyway. And he said, this was the Secretary of State for the Department for Energy and Climate Change. Our position is challenging enough. I can't go with the message that 2 degrees C is impossible. It's what we've all worked towards. So across the board, everyone's saying we can't be honest about 2 degrees C. I was at an event recently, a Chatham House event, so I can't tell you who was there, but a very senior government scientist and someone very senior from a company, an oil company, that looks like something you might find at the beach. These very senior people said, well, I think we're on for 4 to 6 degrees C, but we just can't be open about it. That is going on all the time behind the scenes, that somehow we can't tell the public. Exactly the opposite, say, of it's what the skeptics say, but exactly the opposite direction. So where's all of this leave us? If it all looks too difficult, then what about a 4 degrees C future? And there are some of you here that will know a lot more about this than me, but I'm using some numbers here based on the Hadley Centre and some other people's analysis. It's very simple, bit of some set of assumptions here, but I think it's important to think about a 4 degrees C future. If we peak by 2020, we come down off the curve at 3.5% per annum, the sort of stuff we've been talking about, we can hold the 4 degrees C. 4 degrees C is doable. It's challenging, but doable. So I'd say it's achievable. So is aiming for 4 degrees C more realistic? And certainly I was at an event the other day and someone said, I can't see what's wrong with 4.6. Why don't we just carry on aiming for that sort of temperature. He was a very wealthy American. But I'm sure there's lots of other people who say the same thing. A lot of us think we can defend ourselves against this sort of changed world. Maybe some of us can. 4 degrees C, global mean surface temperature. You're probably talking about 5 to 6 as your land temperature, because remember, a lot of the global temperature is held down by the thermal inertia of the oceans. So the oceans themselves actually keep the Earth cooler. So if the global average is 4, then the land temperatures on average will be higher than that. But you see very large regional variations, and that's what really matters, are these regional variations. And let's be blunt about that again. The science is really very, very uncertain on this. This is an area that really needs a lot more work. So if we think of this is stuff that came out of Hadley Centre, look at the hottest days of the year. So think of the 2003 heat wave in Europe. Just think of China, in Beijing and Shanghai. If you look at the buildings that are going up there in other parts of the world as well, during their hottest days of the year, you'd have a 6 to 8 degrees C temperature rise. And that could last, remember, for quite a long time. So the hottest days of the year with a 4 degrees C global average. Imagine the 2003 heat wave. And imagine that we knocked on top of that 8 to 10 degrees C. Now, somewhere between 20 and 30,000 people died during that. We've got Victorian infrastructures. Our tubes won't work. There's lots of the things will not work in that sort of world. We're not being designed for that sort of future. Certainly not with the populations that we have and the urban heat island effect on top of it. 10 to 12 degrees in New York. I mean, these are high, really very high temperatures that you just simply, our infrastructures and the way that we live our lives could not deal with these things. And you remember in London, is it 3 days food? And this could be a good thing. There's 3 days food in London. At those sorts of temperatures, you may find there's no transport network. So in 3 days, things won't be working. And your fridges probably won't work because your air conditioning units will be blasting away, so you'll probably be blowing the fuses on the grid. So this is not a world that we know how to contemplate. And at 4 degrees C, if you think in lower latitudes, the estimates are that you see significant reductions, 30-40% reductions in some of the staple crops, maize and rice and so forth. At the same time, the population is heading towards 9 billion. So this is the sort of 4 degrees C world. And so I mentioned some people I do know here will know a lot more about this than me, and if they take this similar view, this is my anecdotal polling of climate scientists who work in this sort of area. I said there's a widespread view that a 4 degrees C future is incompatible with the organised global community as we see it today, particularly going forward with 9 billion people and all the other stresses that we face. It's likely to be beyond adaptation. There's lots of this we will not be able to be able to adapt to the impacts. We'll just get hit by the impacts. Some of us might be able to adapt, but many people won't. And it's devastating for the majority of ecosystems. Ecosystems always change, but this is a very, very fast rate of change. And the ecosystems probably are not tuned to changing at this sort of rate of change. And also, there's quite a high probability of this not being stable. Many scientists would suggest as you head towards these temperatures, you get other feedbacks kicking in. Some people call them tipping points, non-linearities. I think we mustn't overplay what we know about those. We don't know when they're going to occur. What we do know is the higher the temperature, the more likely it is that they'll occur. So a prudent person would perhaps keep the temperature rise low. But then it would go up to some other temperature, 4, 5, 6, 7, 8, wherever it might stabilise out at. But again, these are things I think there's still a lot of science to do. So I would say, I go as far as to say 4 degrees C, we should avoid at all costs. Now, before we despair, this is all a sort of message of doom and gloom. What can we do about it? What can we in this room, what can other people, policymakers, what can we do from the bottom up, what can we do from the top down about this? They've all got a clock, no clocks anywhere, I have no idea what. 5 to. Does that mean they're finished now? Is anyone still awake? There's a little bit of good news coming up. I'll try and whip through this a bit quicker. Sorry, I should have put a clock out so I can keep an eye on things. Just to give you a handle, this is the sort of reductions that we need to see in the wealthy parts of the world. This is for an outside chance of 2 degrees C. We need to have about 10% per annum, if not a bit more than that really, from energy. So we need about a 40% reduction in the next 3 years in our energy consumption. That's all of our energy consumption, not just the bits you want to measure. That includes planes, that includes ships. 40%. A 70% reduction by 2020, and basically be completely decarbonised by 2030. Fridges, planes, ships, cars, everything we do, projectors, power system, everything, decarbonised. To give a little bit of space for the poorer parts of the world to help them develop and improve their welfare. So that's what we'd have to try and do, and that will all say that that's impossible. But the question I was asked, which you probably can't see at the back, is then, is living with 4 degrees C temperature rise by 2050 to 2070, is that less impossible? The future is impossible, which as an academic I quite like, because it means you would think you see lots of research grants saying, well, how can we make the impossible possible? We don't get that. We just say, how can we incrementally twiddle with this system again? So whatever you do, the mitigation future is impossible, and the adaptation future is impossible. And then we've got ourselves in that position tough. We've done nothing about climate change since Rio, and we've knowingly done that. So are there any things that can move us in the right direction? The first one of these I'm going to talk about is agency, and the second one is about, equity, and the second one is technology. I'll whip through these quite quickly. This is just a guideline, but there's 7 billion people on the planet. Who needs to make a change? It's not about population. Climate change is not about population. Climate change is about a small group of people, and we know who they are. We see them when we shave, when we put makeup on, we see them in the mirror. So sustainability is a 7 billion person issue. Climate change is not, because it's about the next it's next day to 10 years, really. Vilfredo Pareto is an Italian economist. 80-20 rule, I use this in engineering for years, it's just called the rule of thumb. 80% of something relates to 20% of those involved, and this is just a guide, and there's some background to this information now. 80% of emissions from 20% of the population, run that 3 times. In other words, do the same thing again with that particular group there, do the 80-20 rule again and that, and do it again, and you get about 50% of the world's emissions come from 1% of the population. Now, some of the other estimates out there, this is for energy, that if you include food, that it might be about 5% of the emissions come from 50% of the population. But actually, food is more evenly spread, because we all eat roughly the same. The peasant and the pauper and the prince eat roughly the same in terms of food, but they don't have the same in terms of energy. So roughly as a guide, 60% of the emissions come from 1 to 5% of the population. And we know who they are. Who's in the 1 to 5%? Well, I don't know if you're all in there, but the sort of audiences I normally engage with, every climate scientist is in there with might be an exception somewhere, but hard to find. Every journalist on Pontificate, I'm a skeptic. Every other OECD academic, anyone who gets on a plane once a year, and if you're after 30k a year, which most students are, and probably some of you will probably earn that much money, then you're probably in that category already. So we're the major emitters. We know who they are. There's no one else to blame. And that includes me, completely. So the question then is, are people like us, the Annex 1 people, but including, of course, about 300 million people who live wealthy lives in China, 300 million, roughly the same population as the slightly smaller EU was. Are we prepared to make changes to our lives now, or have them forced upon us? Or are we prepared to hand over to our children, or even later on in our lives, a much, much higher climate change future? So there's a lot that we can do. We don't require the whole world to do something. We require a small proportion of the world to change what they do today for the next 10 or 20 years while we put low carbon supply in place. Then we can go back to our old profligate lifestyles, except for some sustainability concerns that might step in. But from a time perspective, climate change is a short-term issue that we have to deal with, and that's why it's not about population. Is there anything we can do technically? And there are lots of things we can do behaviourally. This is one quick one. If you want to provide light, these light bulbs are a very good example of that. If you want to provide light, you need electricity, a transmission network, a power station, and some Venezuelans dig the coal out of the ground for you. So you put the light in here, 10 useful units of light producing your lumens. Your light bulb here is 80% heat, 20% light, probably slightly better for halogen, but not much better. You'll lose 6 to 10%, probably 6 to 8% in your transmission and distribution network, most of it in the low voltage distribution system. Your power station will be at 35 to 45% efficient, and you'll lose 10% of your energy, at least getting the stuff out the ground, onto a train, onto a ship, brought over here, another train into the power station. So you add all that together and say, well, if we do something here, we save a lot over here, don't we? But all of our focus is on this. Everything's on this. But remember, this is what we do. So this actually says this is very much about an issue for us. We can do a huge amount here and have massive repercussions across the system. And just about cars, now notice this is without rebounding, it's an important issue here, we're not assuming you're going to drive further. The typical car, and I'm pointing that to politicians, they ask me, why aren't we doing it? The politicians ask me why they aren't doing this. The UK typical car, 175 grams of carbon if it's driving past outside at the moment, and UK on the forecourt, 150 grams of carbon dioxide it emits per kilometre it travels. The EU really stringent plan for 2015 is 130 gram of CO2 per kilometre, and you can buy your way out of that if you're a professor or Clarkson or some other fool. You can pay for your four-wheel drive if you don't feel you've got enough status from your actual own personality. And so we then look at what's available today. There's a blokey car here. Well, that's that sort of car, Clarkson type car. 2008 BMW, it's one of the 3 or 5 series. It's 160 horsepower and all sorts of things. It's got 4 seats. It'll do 109 grams. I've got a friend of mine's got one of these, and he likes it because he's a sort of sporty boy racer type, but he puts his whole family in it, and he's getting 65 to 70 to the gallon out of his BMW, particularly when he's got his family with him. He drives more carefully then. But VW is 85 to 99 grams. Audi, that came out in 1998, at 75 grams. Now, admittedly, when you drive these things, they're not that good. They're about 10% to 20% more than that. But these are what we can do now. These are not new technologies for the future. These are not hybrids. They're not electric cars. They're diesel cars you can buy now for no price premium, virtually no price premium. So why is it we're putting policies in for that in 2015? If you actually said, well, the important point is that 90% of all vehicle kilometres are travelled by cars that are under 8 years old. That's called the DFT, Department for Transport. So most vehicle kilometres are travelled by newish cars, particularly the first 1, 2 and 3 years. So we know the normal scrappage rate, you can actually swap the system through if you put a policy in place to say you have to buy this sort of car, this sort of standard. You'd have about a 40 to 50% reduction in CO2 by 2020 with no new technology, at no price cost, at no hybrids, at no electricals. And if you said let's reverse the occupancy trend, so in other words we have slightly more people per car without, I think we're about 1.3 now, so we went back up to 1.8 people per car. And obviously someone asked me recently, how can it be 0.3? Hope you realize, it's an average, so we're not saying it's one in a leg or something. So if you reverse that, you can head back towards a 60 to 70% reduction in emissions by 2020 or 2022. In other words, we can do what we have to do to give us an outside chance of 2 degrees C for a wealthy part of the world from cars. So there are plenty of things that we can do technically. So what's happened here? Final couple of slides now. If we think about some conservative assumptions that I've made here, if the science is broadly right, if cumulative emissions and temperature broadly hit together, if the non-Annex 1 parts of the world, the poor parts of the world, can peak their emissions by 2025 to 2030, if there are rapid reductions in deforestation, and if there's a big significant improvement in how we produce our food, eating less meat, different types of agricultural practices, if there are no tipping points out there, if the feasible rates of reductions of 3 to 4% per annum are achieved, as per the economists tell us, then 2 degrees C stabilisation is virtually impossible. So if we do everything that we say we're going to, if we do everything we say we're going to do, but that we're not doing, then we still can't hold to 2 degrees C. And 4 degrees C by 2050 to 2070 doesn't seem unreasonable if you look at the current projections of emissions. I mean, that's quite a sad indictment of where we are, and quite a sobering message. But I've got to say there are lots of things that we can do, both from the bottom up and from the top down. But this is actually what got through in the paper, the World Society paper. This is not meant as a message of futility, as it often said, it was just futile. It's a wake-up call of where our rose-tinted spectacles have brought us. Real hope, and that's the only thing I'm interested in, real hope, if it is to arise at all, real action, real hope, if it is to arise at all, will do so from a bare assessment of the scale of the challenge that we now face. And that's what I've tried to show here. This is where we are today. If we know where we are today, we know what the scale of the problem is. If as scientists we keep underplaying it, we don't know it. And I'll leave you with a quote from Robert Unger that I always finish off with. At every level, the greatest obstacle to transforming the world is we lack the clarity and imagination to conceive that it could be different. Clarity and imagination, that's what we need. Lots more of that. And then I think we could actually deal with climate change to a degree. Thank you very much.